As we look structurally at the cerebrum, there have been some unusual CT findings. Some studies have shown left hemisphere processing deficits that interfere with the integration of various brain systems. There have been various theories suggested there have been left hemisphere damage, right hemisphere damage that has been assessed by behavioral observation. As we move to the cerebellum, that assists in our emotional regulation, which is often an issue in children with autism, and higher level thinking. It also helps with anticipation and preparing for upcoming events. It contains the Purkinje cells, which is the brain's kind of filtering system, knowing what to pay attention to, what to not pay attention to, what to disregard. So for instance, if you had long pants on one day and short pants on another day, your brain would be able to filter out those different sensory information thanks to the Purkinje cells. So when we look at children with ASD in the cerebellum, we realize that they can associate the information that's coming into their brain, but often those associations are unusual. And then those inappropriate associations then make predictions difficult because they have the wrong facts from what's happening and associating, which makes it harder to figure out what's going on, to predict what might happen, to make appropriate changes when the situation is dynamic and changing. So therefore, it's easier for them if things stay predictable or stay the same, because moving to unpredictable or dynamic changes in what's happening is so hard for them. Some studies have shown that some individuals with autism have less of that filtering system cells, 20 to 30% less, which is pretty significant. So what happens when you have less Purkinje cells, all sensory information assaults the brain with the same importance, and it's hard for you to filter it out. So the light coming from, or the buzz from the light has the same importance as the teacher, per se. So it's hard really to focus on what's important. There's also a high association with seizure disorders. There's much higher incidence of seizure disorders in ASD, particularly as they move into adolescence. So as infants, there's a higher seizure disorder rate, and then also as they move into adolescence, that also is a time where we need to be kind of vigilant to make sure that they're not developing a seizure disorder at that time. So let's talk about the idea of neural plasticity. Our brain changes due to maturation and experience, and in fact, every experience that we have actually changes our brain circuitry. So even though we may look behaviorally the same, our experiences do change our circuitry. So let's pretend we take two cats, and one cat has a blindfold on for, say, a month and cannot use their vision, and the other cat does not, or a kitten does not. So those two kittens at the end of that month will look behaviorally very much the same, but their brain circuitry will be different because the kitten who had been blindfolded during that month will have not had the same experiences, and they won't modify their neural circuitry that way, and they may create different novel circuitry than the little kitten that could see. So neuroplasticity allows for a compensation ability in the brain. So if you can't get there one way, you can get there another way. That's pretty impressive. But the plasticity is more, say, elastic and moving when children are young than they are later on in life. However, they used to think, oh gosh, after adolescence, that the brain is just stuck and there's no plasticity involved, and that's not true. They've realized now that you're never too old for your brain to grow and show this kind of plasticity, which is really fascinating. When they've looked at neuroplasticity, they haven't pinpointed any one area of the brain, but they do think neuroplasticity may contribute to abnormal development in ASD, because there's an extension of disrupted functioning. You're creating different circuits, and then those different associations create different neural circuitry and neural systems. So, for instance, in the beginning, you're not really drawn to faces as much as other people are, so you have a more asocial kind of experience, and then that modifies how your neural circuitry is, and it creates novel circuitry that's focused on something else.